Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of relations and functions. We are discussing the examples of the functions here. First we have two questions based on whether a relation is a function or not. Alright, so understand the concept. When do you think a relation is a function? What is the definition of a function? If every element of A has one and only one image in B. Okay, so if every element of A has one and only one, every element must be related. Okay, and every element must be related to only only one element. It should not be related to more than one element. You have one, it should not be related to two elements. It should be related to only one. Okay, but two elements can be related to one, accepted. Okay, well, so let's understand which of these four functions given as f1, f2, f3 and f4 are really functions. They are all relations. They are all relations. We have to check which of these relations are functions. So what I do here is I'll take two sets here, A and B. Okay, so you got 1, 2, 3 and 4. Now you got 1, 2, 3, 4 here as well, because this is a relation from A to itself, A to A. This is a relation from A to A. Now let me use this as the function. What is y? F of x. So f of x is x plus 1. Alright. So what is y if x is 1? So 1 goes to 2. Is it not? Correct. Then what about 2? If you put 2 here, y is equal to 2 plus 1. So y is equal to 2 plus 1. That means 3. Okay. And if you put 3 here, that is 3 plus 1, 4. What about 4? 4 plus 1, 5. So 4 goes to 5. But do you have 5 in the set A? You don't have that. You don't have that. So you cannot draw an arrow here, because 5 is not there. So where will you draw that arrow to? You cannot draw that arrow to anything, correct? You cannot draw that arrow to nothing. There must be 5. You don't have 5 in that set. You have only 1, 2, 3, 4. Therefore 4 is not related to anything. So what is the first condition to become a function? Every element must be related. Now 4 is not related at all. So if 4 is not related, then you cannot say this is a function. Therefore this is not a function. Now let's go to the next. So what about the second? X plus y must be greater than 4. So what are the different elements you can take? You can take 1, 2, 3, 4 in place of x. So you take 1. Okay, so then what will be y, so that x plus y is greater than 4? You must take 4 here. You can't take 3, correct? Because 1 plus 3 is equal to 4. It must be greater than 4. So you can take 4. Okay, so 1 is related to 4. I hope you understood. If x is 1, y is 4. Next, if x is 2, then this can be 3 or it can be 4. You got two values, correct? So 2 is related to 3 and 2 is related to 4 as well. Now look at this. One element is related to 2. As you continue, you get similar types here. See, if you take x is equal to 3, then you can take 2, or you can take 3, or you can take 4. You have got 3 values. So 3 is related to 2, 3 and 4. You cannot have any element related to more than one element. Correct? Every element must have one and only one image. You cannot have two images. One element cannot have two images. One person cannot have two mothers. Correct? Okay, keep that imagery in your mind. Alright, you cannot have that. One person has only one mother, but two people can have single mother, right? Brothers and sisters. Yes. Okay, so keep that image in your mind, you will clearly understand. Now 2 is related to two elements here, therefore this is also not a function. That is also not a function. Let's move on to the next. See, the next thing is y is less than x. So once again you have a and a itself. Okay, so a to itself. Correct. Now if I take x is equal to 1, what are the values I can take here? What are the values I can take? You must take the values which are less than 1, right? So do you take 1 goes to 1? Can you write 1 goes to 1? You cannot, because 1 is equal to 1. 1 is not less than 1, right? Y should be less than 1. Which is less than 1? Nothing is less than 1. So you don't have any arrow starting from 1. Let's move on. Okay, so let's have some arrows. So what about 2? So can you write 1 here? Yes, 1 is less than 2. So 2 is related to 1. X is 2 and these are y values. Keep that in mind. Okay, so I can write 1. I got some value there. Now what about 3? Okay, so 3 is related to either 1 or 2. So 3 goes to 1 and 3 goes to 2. Both these values are less than 3. Correct? Yes. Similarly 4, if you have 4, then you have 1, 2 and 3. So 4 is related to 1, 2 and 3. So just one example is enough. See, 1 is not related to anything. So first condition is failed there. What is the first condition? Every element must have an image. Every element must be related to something. But here 1 is not related. The second thing is 3 has more than one image. Every element should have one and only one image, whereas 3 has two images. Therefore that is also not a function. This is also not a function. So what is left is 4th, and that should be a function. Okay, then only the purpose of this question is fulfilled. Okay, so 1, 2, 3 and 4. So here also you got 1, 2, 3 and 4. Now F4. Okay, so x plus y is equal to 5. In other words, y is equal to 5 minus x. So if you write this equation in a simple way, so we'll get y in terms of x. Now you go on substituting the values of x here. So in place of x I'll take 1. So then what will be y? 5 minus 1, 4. So 1 is related to 4. Correct? So if I take 2, then what is y? 3. So 2 is related to 3. Then if I take 3, what will be y? Y will be 5 minus 3, 2. So y will be 2. These are x values and these are y values. Okay, then if I take 4, then 5 minus 4, that is 1. So 4 is related to 1. So 1 is related to 4, 2 is related to 3, 3 is related to 2 and 4 is related to 1. That means every element is related to some element on the other side, and every element has one and only one image. Do you see any element having more than one image? No. 1 has only one image, 2 has only one image, 3 has only one image, 4 has only one image. That means it is a function. Both the conditions are satisfied. Therefore option D is the right choice. Well, so that is about the first question. We understood clearly what is a relation and which relations are functions. Okay, all these are relations, but only f4 is a function here. Let's move on to the second question. The second question, the relation are from A to B, where A is 1, 2, 3, 4, 5 and B is U, V, X and Y and Z. Right. Now let's go to the first option. Here also you have to say which relations are functions here. Okay, only one of them is a function. Let's identify that. Okay, let's go to the first option. What does that say? 1 and U are related to each other. That means 1 is related to U. Well, what about 2? 2 is related to V, and 3 is related to V as well. Okay, and then you have 4. 4 is related to Y. That's it. So 5 is not related at all. 5 is not related at all. That means every element is not related. So first condition is not satisfied, therefore it is not a function. This is very easy to understand because it is given in the roster form. All the ordered pairs are listed. Let's move on to the next function, the second one, next relation. Let's see whether it is a function or not. So you got 1 comma Y, 1 is related to Y, and 1 is related to U. Well, 2 is related to X, and then 3 is related to Y, and then 4 is related to Z. Okay, let's not write those arrows, because just this is enough to say that one element has more than 2 images, more than one image, because one has 2 images here. Okay, one element, any element can have only one image. It cannot be related to 2 different images. It's not a function. It's not a function because of this, because 1 is related to 2 different values of Y, 2 different elements. Now let's look at the option C. 1 is related to U, and 2 is related to V. 2 goes to V, and 3 goes to X here, and then 4 goes to Z, and 5 goes to Y. Well, now look at this. Is it a function? Yes, because every element is related. Yes, and every element has one and only one image. No element has more than one image. No element goes to 2 images, right? So therefore C is the function. Now what about D? Actually in the exam you can stop here because you got the answer already, but now let us understand and see why D is not the right answer. 1 is related to U, 2 is related to X, 2 is also related to Y. See, this is the reason. This is the reason. You have the element 2 which is related to 2 different images. This cannot happen if it has to be a function. Therefore, this is not a function. This is not a function. Well, so that's about the second question. Okay, so which is the right option? Option C is the answer. Well, let's move on to the third question. Hello dear students and welcome to CET JEE classes. Let's go through the third question of functions. A is given 1, 2, 3, 4, B is 1, 5, 9, 11, 15 and 16, and the function f, okay, it's a relation or a function, is defined as 1, 5, 2, 9, 3, 1, 4, 5, 2, 11. Consider 2 statements. Statement A is f is a relation from A to B, and the statement B says f is a function from a to b. Now which of the following is true? So do you think a only is true, or do you think only b is true, or both a and b are true, or neither a nor b? Let's understand clearly the difference between relation and a function. First of all, what's a relation? See, you have the set A, that is 1, 2, 3 and 4. You got A cross B. Okay, you got the set B as well. Okay, that's here. Now what is A cross B? 1 comma 1, 1 comma 5, 1 comma 9, 1 comma 11, 1 comma 15, 1 comma 16 and so on. So there are many elements. How many elements are there? 4 into 6, 24 ordered pairs are there. So I am not going to waste my time in writing those. Okay, so if you need some examples, 1 comma 1, then 1 comma 5, 1 comma 9 and so on, starting with 2, 2 comma 1, 2 comma 5, 2 comma 9 and so on. So all those things are there. Anyway, now what's a relation? Relation is a subset of the cross product. Okay, now you have to check whether this is a subset of A cross B. If it is a subset, then it will be a relation. Okay, now do you think 1 comma 5 is there in A cross B? Yes, you got 1 comma 5. Yes. What about 2 comma 9? Yes, 2 comma 9 is also there. What about 3 comma 1? Yes, 3 comma 1 is there. And 4 comma 5? Yes, 4 comma 5. And what about 2 comma 11? Yes, you have 2 comma 1, 2 comma 5, 2 comma 9, 2 comma 11. Everything is there starting with 2, right? So all these elements are the subsets of A cross B. Therefore it is a relation. So F is a subset of A cross B. Therefore F is a relation. F is a relation. Now to check whether it is a function or not, you have a different criteria, correct? So you draw the arrow diagram that makes it very clear. So let me draw the arrow diagram. You have 1, 2, 3 and 4, and here you have 1, 5, 9, 11, 15 and 16. That's the set B and this is A. You have the function between them defined in the roster form here. Now 1 goes to 5. Okay, so 1 goes to 5 and 2 goes to 9. Well, 2 goes to 9 and 3 goes to 1. Fine, 3 goes to 1 and 4 goes to 5. Fine, 4 goes to 5 and 2 goes to 11 again. Look at this. What are the two conditions of a function? Every element of A must be related to some elements of B. Yes. So do you think every element is related? Yes. Arrows begin at every element here. Fine, that is satisfied. What is the second condition? The second condition is that every element should not be related to more than one element. Correct? So every element must be related to only one element. So what about 2? 2 is related to two different images. So 2 is related to two different images. 2 is related to 9 and 2 is related to 11. That means 2 has two images. The element 2 has more than one image. Hence it is not a function. So it is not a function. So the statement B is not true. So only A is true. B is not true. A and B are also not true. Neither A nor B is true. No, A is true but B is not true. You cannot say that both are not true, right? Therefore the option A is correct answer. Let's quickly move on to the fourth question. Hello dear students and welcome to CET JEE classes of relations and functions. We are dealing with the examples of functions and we are in the fourth question. The fourth question is, if f of x is equal to 2x square, find f of 3.8 minus f of 4 divided by 3.8 minus 4. Well, so these are the options. Let's see what is the right option. So what we need to find is this quantity. So what is f of 3.8. See, f of x is 2x square. Now in place of x you got 3.8, therefore this must be 3.8 square, is it not? Yes. So if that is understood, we can continue with the given expression. The given expression becomes two into 3.8 square minus 2 into 4 square, if you understand, correct? Because f of 4, what is f of 4 here? 2 into 4 square, that's what I have written there, and there is no change here. So this is 3.8 minus 4 itself. Now I can take 2 common, is it not? Okay, so this will be 3.8 square minus 4 square. I have just taken this 2 out. Okay, so why have I done it? You will understand in the next step. See, now what I can do is I can write this quantity. See, this is a square minus b square, so I can write it as a plus b into a minus b, correct? So that's what I will write next. So next what I'll do here is see, this is 3.8 plus 4 into 3.8 minus 4. Okay, so you no more need this bracket because it is all multiplication, and divided by 3.8 minus 4. So what do you get? What do you get next? You cancel this quantity. Now you are left with 3.8 plus 4, and that is 2 times. So this is 2 into 4 plus 3, so that is 7.8. So 7.8 into 2, so 14 plus 1.6, that is 15.6, and that's the right option. So you don't have to use the calculator to find 3.8 square and so on. So that calculation is very complicated, whereas this method is the simplest, and this is the method you can use for CET because you are not allowed with the calculator there. Well, now let's move on to the 5th question. The 5th question is, okay, now we are moving in to the next concept of finding the domain of a function. So please recall the rules of finding the domain. We have already understood those rules. I am sure you know them now. Okay, so if you have an expression like 1 by the expression, then the denominator should not be 0, correct? Okay, so the first thing that you need to understand here is under root 9 minus x square should not be 0, because it is the form of 1 by expression. So expression should not be 0 in the denominator. Why denominator shouldn't be 0? If the denominator is 0, then 1 by 0 is not defined, then function is not defined. Okay, if the function is not defined for any value of x, that is not there in the domain, right? So what is the meaning of domain values? Only for those values for which the function is defined. So if the function is not defined, the particular value cannot be in the domain, so that value must be avoided. Now under root 9 minus x square should not be 0, that's the first thing. So if under root 9 minus x square should not be 0, so whatever is within the root also should not be 0. So that means 9 minus x square is not equal to 0. And the next thing is, do you see the square root? Yes. So if you have the form of square root of expression, then this expression should be always greater than or equal to 0. So that cannot be negative. If you have negative within the root, that is also not defined, that goes to complex, correct? It's not a real value. We are dealing with the real functions here. Okay, so just by looking at this f of x, you should decide that this is f from R to R. This is not defined on complex. It is always a real function. All right. So now what is the expression here within the root? Within the root in the denominator you have 9 minus x square, and that should be greater than or equal to 0. Now look at this, 9 minus x square should not be equal to 0, and now we are saying greater than or equal. Okay, so combining these both, now we say equal is also not possible. So therefore combining these two things, what we get is 9 minus x square should be only greater than 0. It cannot be even equal because of this. Therefore 9 should be greater than x square if you bring that to the other side, or in other words adding x square both sides. Okay, so that means x square is less than 9. So when do you think x square is less than 9? If x is less than 3, all right, and x should be greater than minus 3, right? So if x is greater than minus 3 and less than 3, then x square will be less than 9. Understand? If you put minus 3 here, minus 3 square is 9. What about minus 2? Okay, so if you put minus 2 here, then that will be 4 is less than 9. If you put 2, 4 is less than 9. So both these satisfy or not? Correct? So that should be greater than minus 3. So combining these both, we can write minus 3 should be less. See, the arrow is towards here, right? Yes. So this is x, and then x should be less than 3. So that's the domain we have, and that's in option B. Hence option B is the right answer. Well, I hope you understood how to find the domain of a particular function. Now let's move on to the next simple examples of finding the domain. See, why do I say that is simple? Because that is straightforward, right? So here what you have is an expression of the type 1 by the expression. So if you have anything like this can be anything, need not be 1 itself, it can be any polynomial there. Okay, so if you have a rational polynomial, rational function, okay, if you have a rational function, then denominator should not be equal to 0. If the denominator becomes 0, then the function is not defined, Well, so in this case, what we must have, x square minus 5x plus 4 not equal to 0, and similarly here the denominator should not be 0, and only for those values of x you will have the function defined. So sixth question, you cannot have the denominator 0. Well, now find the values of x for which this becomes 0. All right, so how do you do this? See, x square minus 4x minus x, so that means x minus 4 and x minus 1, that means x cannot be 1 and 4. Okay, so x cannot be 1 and 4, and it can be any other real number. See, x values are here, you can have any real number in place of x here, but not 1 and 4. So from real numbers you must subtract the set containing 1 and 4. Don't write like this. What is the difference between these? Here you got only 1 and only 4, only two integers. Here you have all the real numbers between 1 and 4. That means you have 1.1, 1.2, 1.3, all the values are there. Don't delete them. Delete only 1. Why delete only 1? Because when you put 1 square minus 5 into 1 plus 4 will be 0. If you put 4 here, 4 square minus 5 into 4 plus 4, that is also 0. So avoid only these two values. Don't avoid 1.1, 1.2 and 2 and 3 and all. Don't avoid them, because when you put 2 you are not getting 0. When you put 3, you are not getting 0. Therefore, don't write like this. Alright. So, what is the right answer? Option B is the right answer. You have to avoid 1 and 4, and all the other real numbers will be the domain. Similarly, the seventh question, here also the denominator should not be 0. That means x square minus 8x plus 2 shouldn't be 0, the denominator. And if you split this, you can write it as 6 minus 2 and that is 12, right. Well, so x minus 6 minus 2, if you take common, you are getting the same, and that means x minus 6 and x minus 2 is not equal to 0. Hence, x is not equal to 2 and 6. Okay. So that means the domain will be all the real numbers except 2 and 6. So here also we are getting the option B. Well, so that's it for today's class. Thank you for watching. We will continue to solve questions of this type, finding the domain, and then we'll go to finding the range. So once again, thank you for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.